Let's go. What's up, everybody? Welcome to the Artists of Data Science Happy Hour. It is Friday, October 15th, 2021. I'm your host, Harpreet Sahota. Super excited to have all of you guys here. Hopefully, you've had an amazing week. I, for one, have been sick the entire week. I probably shouldn't be drinking beer just because of the sheer volume of acetaminophen that I have ingested. But I'm going to do it anyways because, I'm feeling a little bit better today, feeling a little bit better. And for that, I celebrate because my health is getting better. Confucius once said that that a healthy man wants 1,000 things, but a sick man just wants one thing. And that is absolutely true. True words have never been said. Hopefully, you guys got a chance to tune into the podcast episode that I released just on Friday with Eric Oken. So this episode was actually the very first conversations episode that I ever recorded. I actually recorded this episode well over a year ago. It was about September 2020 when I recorded this episode. So I'm interested to go and listen back at it to see how much I've changed since then. I wonder what kind of shit I was saying in that episode. So I'm excited to have all you guys here. A lot of cool stuff happened this week. I was on the Data and Impact podcast hosted by community member Christian Steinert. So thank you very much for having me on the show, Kristen. Had a cool episode release with that I saw on the Ken's Nearest Neighbor podcast with both Ken G and Mark Freeman. I thought that was super cool to see that happen, man. Epic collaboration there. A lot of other cool stuff too, man, happened this week. Did two presentations this week, one at the ML Conf that was just earlier today, and did a in-house kind of presentation for our house list at Comet ML. And so that was a lot of fun, man. Hopefully you guys got a chance to check that out. If not, don't worry. I'll be giving presentations for quite some time. Shout out to everybody in the room. What's up? Ben Taylor, Ken G, Russell Willis, Eric Sims, Auntie's in the background, Makiko's in the building. So is Alexandra. Super excited to see all you guys here. So, man, I got a question for you guys. Let's open it with this. I'm wondering what does it mean for a data scientist to be creative? And is creativity a necessary skill for success as a data scientist? I'd love to get your thoughts on this. Let's go to Ben Taylor first. And after Ben Taylor, go to Ken G, then Eric Sims. And anybody else wants to chime in, please do let me know.
So I think there's a lot of people in the data science community that are not creative. And I'll give an example. So if I said, elderly slip and fall, let's go fix this. We're going to go do this initiative to fix elderly slip and fall with AI. Most people would say, we're going to do video cameras in the hallway. We're going to look at you. You're going to fall. We're going to build an AI model. And I would say the creativity with that is horse blinders, like they're navel gazing. And I think the distinction, I'd say, don't think like AI, don't think like some narrow scope perspective, think like a human. So what would a human do? Well, a human would you'd have lots of cameras, but more importantly, a human would be reactive to, oh, it's 8 a.m. You didn't wake up for breakfast. I have a problem with that. Normally you're here for breakfast, or you went to the bathroom and you've been there for 30 minutes. I'm getting concerned. 2 hours. I'm very concerned. And so I think too many times in data science, it's extremely narrow, which I don't know why that is, because data scientists are typically really smart, but I see a lot of data scientists that they see the world like this rather than seeing the world like this. So I'm curious how other people react to that. That is a lack of creativity a problem in the data science space, and why do so many people take the approach of hot dog, not hot dog, I'm going to do a cancer classifier, rather than taking the approach of like, what would a human do? I'm going to take all the data that matters. So I'll be quiet to that.
Yeah, it's a good addition to that question. Let's go to Ken G, and then after Ken G, we can go to Eric and then Russell. And anybody else wants to jump in on this one, please do. So the opening question is, it's about creativity in data science. What does it mean to be creative in data science? And is creativity a required skill for success in data science? Also, shout out to everybody else that just joined into the room, Gina and Truck. See you guys. Ken, go for it.
So I'm going to make the bold statement that I believe creativity is integral to the success of most fields, particularly data science, right? But I think the way that we define creativity is something that varies greatly, right? Like there's different levels of creativity. Like you can be very creative in the model training process, right? You can be very creative in the feature engineering process. You can be creative in the questions you ask or the ideation process, or, as Ben described, the way that you approach certain problems. And I think that in order to be successful in this domain, you have to be creative in at least one of those areas. But most people are not creative in like all of those areas or multiple of those areas. And I think that something we should all seek to do better is think about, okay, where is our creative strength, right? Like I personally think that when I'm explaining things, I come up with creative ways to view them, analogies or different ways to present information that would help someone else digest it, right? Like that is a creative strength of mine. On the other side, a lot of the times when I'm doing like actual data science work, I find myself doing a lot of the same things over and over again because they've worked historically or whatever it might be. I'm not flexing the creative muscles as much as I probably should be doing. That could lead to greater insight, a better understanding of the problem, or it could potentially even show that the way I've done things in the past was not a good way to do them to begin with. So I think that, I would answer this question in a really annoying way with another question is like, how do we define this creativity? And, are there better ways for us to practice and exercise creativity in the different compartments of our life or the different compartments of our work?
Very good, Ken. Thank you so much. Appreciate that. These are excellent comments and excellent, things to think about. Eric, let's hear from you, then Russell as well, then Makiko's no filter response. I want to hear that as well. And by the way, everybody listening on LinkedIn, on YouTube, in the chat here, please do let me know if you got a question. Just comment or write right here into the chat that you got a question. I'll add you to the queue. Go for it, Eric.
So I would say that creativity is, oh man, I got the live stream going on this other monitor. Got to turn that off. Okay. So creativity to me is approaching something in just the way that's different from the people who are in your immediate vicinity, right? And so, because you could be a tremendously uncreative, let's say, artist compared to the artists that you maybe spend most of your time around, then you put yourself in a different situation, and all of a sudden you are tremendously creative because you bring a perspective that nobody else in that group brought. And hopefully that can even like unlock creativity or new thought, previously unhad thoughts with other people, and it doesn't necessarily mean that you are, I guess, artistic, we usually kind of say it like that, but I think it's just bringing your own thing to that environment. And so that's why I think it's really some of the best advice I ever got from a previous boss was he just called it dig your own job. And so I was like, oh, dig your job, like enjoy it. He's like, no, dig your job as in you're all here being, analysts or data scientists or whatever you are, but like find your spot, dig into it, and don't let anybody get you out of it because you are the best at that thing and you bring that to the table, and then you can just get really good at it and be that awesome person that helps lift the team with what you bring. So that's kind of my take on creativity. But at the same time, I also just like coming up with goofy and original things that maybe people haven't thought of before because it's just fun.
I love these responses. Thank you very much, Eric. Ken and Makiko doing the Aloha Friday. Ken's asking, where's my shirt, dude? It's full on winter here now in Winnipeg. It's like 48 degrees, cold and rainy outside. It is firmly cashmere season for me.
Aloha is a mindset.
That's true.
Not a temperature. Yeah? Come on.
Yeah, that's true. I gotta find some floral sweaters. I bet I could find some of those.
Same with Hakuna Matata.
There you go, man. Straight up. Makiko, give us your hot take on the question at hand. Remember, folks, we're talking about creativity and data science. What does that mean? Is that something important to success? Let's go to Makiko, then Russell, and then Gina. I see you have a comment here. I'd love for you to share that with us.
Yeah, so I think so when I think creativity in data science or lack of, I'm gonna be honest, I'm thinking adults. Because kids and teens are definitely, before it's speeding out of them, they're remarkably creative. and intelligent and funny and all that. But I think in terms of like the rest of us older folks, I feel like a lack of creativity honestly comes down to like empathy and world experiences. And you see this a lot, I feel like, for example, on the product side, where I don't know, like people either don't dog food their own product or whatever. And so, so their users will complain about like, we can't do this, or it's not like flexible, it's not user friendly, like whatever. And the engineer will go like, no, it's perfect. Like it's built like this. And it's like, have you, Mr. or Mrs. or person engineer, have you actually tried like using your software? Because it's not pleasant. Or things, for example, like, and this can kind of be one of those challenges if you're, doing modeling or analysis in a domain that you have no experience with. Like, for example, medical or sports. If you tried tossing me at a baseball problem, I'm sure I would screw it up, and Ken would have lots of things to say about it. Like, why didn't you try this? Why didn't you do this? Why didn't you do that? Because sports to me is like you throw a ball at someone, maybe at their face, maybe across the field, who knows? But you'll run into that. And I think it's one of these weird things where like, it feels like the solve would be to just like practice empathy, try out different life experiences, try doing work in a different domain, try doing a Kaggle competition, whatever, right? But like literally just expose yourself to something new and take yourself out of your like current status quo. And I don't think a lot of people do that because of like the whole explore and exploit trade-off, right? Like they kind of want to stay in the pocket of what they're really, really comfortable with, but that means that they end up missing out on like the big value opportunities, which a lot of times are out of your comfort zone. So I know it's not a hot take, it's a lukewarm take, but
I like it though, Makiko. Thank you so much. Russell, let's hear from you on this, and then Alexander, if you'd like to jump in here. Sorry, we'll go to Russell, then Gina, then if Alexander wants to jump in, I'd love to hear from you. Also, shout out to Dylan. Good to see you here again. My friend, it's been a while. Joe Reese is also in the building. What's up, Joe Reese? Russell, go for it. Then we'll go to Gina, then Alexandra. And then, by the way, anybody listening, like I said, we're taking questions. So if you got questions, let me know. I'll add you to the queue.
Thank you, Harpreet. Evening, everybody. So I agree with everybody's statement so far on creativity. I put 2 comments in the chat. The first was saying creativity isn't essential for anything, but it certainly enhances and can accelerate most tasks or actions or anything that you need to do. But if we take creativity as like a dictionary translation, it means to create something. So if you write some code, you're creating it, therefore you're creative to a certain extent. So I think Ken's earlier comments about exactly what creativity is were very pertinent. So my first comment was taking creativity to be, to the extent, a really creative person that can come up with some out of the box thinking. Okay. And then my next comment was saying that creativity is generally inversely proportional to orthodoxy. So if you learn one way to do something and you do it that same way every time, that's a status quo, that's the orthodox approach, you could be deemed to be low creativity. If you change it up and you bring learnings from something else into it, which may bring good or bad results, but you're doing something different and can learn from all of the positive aspects from that, then I would deem that creative. So say, for example, we weren't talking about data science, say we were talking about cooking your evening meal in the kitchen. You cook the same thing week on week. You not be very creative. You cook different meals each day of the week, you'd be a little more creative. You cook different meals every day for say a month, a bit more creative. Then you mix up those meals. Every time you cook the same meal, you throw something different in it. A different herb, a different seasoning, a different ingredient. You just change stuff up. You're even more creative. So there's definitely a scale of creativity. And in my opinion, creativity will help everything, even coding. So as I say, if you've used one function or command to get a certain return in some code, and one day you shake it up and try something else, you may find that you can come up with the same result in, say, 10 steps rather than 100 steps, and find that it's going to, really improve the efficiency and the performance of the model. So creativity there, I think, definitely enhances, but the bare bones basic creativity will get you by. It'll just be a bit more boring, should we say.
Thank you very much, Russell. Gina, let's hear from you. Then after Gina, we'll go to Alexandra.
Yeah, hi. Great to be here again. This is my second visit to Data Science Happy Hour. I have a lot of thoughts on creativity, but let me just limit it to a couple and kind of piggybacking off of Russell's answer. So I think a lot of times, like related to what Makiko said, and then also clarified that, of course, children are often creative because no one's told them you can't do this or that until they tell them, oh, that's stupid, or that's not the right way to do it, or et cetera, et cetera. And so along the lines of what has previously been said, I think aside from all the other influences, school, family, et cetera, both the organization you're in and the organizations maybe that you've been in the past, you're going to respond. Everybody is going to respond to the incentives that are presented to them. And so stepping aside from data just for a minute, I could tell you I've been in a number of organizations and I've almost kind
of... Gina, you somehow went mute. You want to unmute yourself? Because you're right in the middle of saying something awesome.
Okay, there we go. Yeah. Sorry about that. That was odd.
Yeah.
Maybe Siri muted me or something. But I think it depends on the organization you're in. And what I was saying is stepping away from the data science side just for a moment. I've been in organizations where I feel like I've been kind of whipsawed in a way. One organization almost mandated, aggressive might be the wrong word, but some organizations, almost require that. If you don't speak up, you've got nothing to contribute. Other organizations are so much more consensus-based, and having come from one organization that was very much the former, and then going to one that was very much the latter, I made the mistake early on of maybe, expressing my opinions a little too forcefully. And I don't think that got me off on the right foot with a lot of people. And so I think I want to put that out there. Sorry, I got a little background noise. To consider that, and in your current organizations, please encourage people to be creative. And if people aren't encouraged to be creative, then maybe they're not going to be very creative. So it's a combination of, realizing that sometimes if people don't seem creative, it might be because that was stifled for them in the past. And so I guess be mindful of what incentives are put in front of people, because I think a lot of people have creativity, but it's a matter of whether or not they were rewarded for expressing it. So I guess the short answer is, don't assume that people aren't creative just because, maybe they don't initially seem to have the most creative answers, even for what they might post in their GitHub or on their profiles. They might be timid about putting something out there because maybe they believe that, they need to show look, I've got down the basics. I can solve these types of problems. In music, it's kind of the equivalent of, man, I've got my scales down. I've got my arpeggios. I've got, all these basic kind of building blocks that show you can at least do the basics, or even technically do more than the basics, but you're not quite at jazz improv.
Absolutely love that, Gina. Thank you so much. Let's hear from Alexandra on this, and then Kostub, I see you have your hand up. Is that to speak on this topic as well? Awesome. So we'll go to Alexandra, then we'll go to Kostub, but then Greg has a question that was left over from last week about compilers. So Greg, if you want to type out the question, put it in the chat so we can prep people about compilers. Alexandra, go for it.
Yeah, I was just going to add, I'm coming from the perspective of being a master's student right now. And I think for me, the biggest hindrance in the opportunity to be creative is really just time. I think that a lot of times we have the innate ability to express that creativity, but then all of a sudden when the professor assigns you 5 more projects that are due at the end of the week, and a teammate comes in with a data set that they've used before and a project idea ready to go, it's really easy to kind of jump on the bandwagon and just go with the low-hanging fruit of what's easy, especially from a college perspective. So I think one thing that I'm really trying to prioritize in the creative data science process that I'm going through is just kind of almost giving myself time blocks, saying if they present a project idea or a proposal today, I'm not allowed to even answer that question until tomorrow or the next day or the end of the week. And sometimes that's not always feasible. We don't always have the pleasure of extra time. But when it is, I think just giving yourself that space, that mental capacity to think about problems, it really helps for me.
It's so important, man. Like that time and space thing. Like lately, I just haven't had much time or space, and I just feel like I just haven't had good ideas. Like my ideas have just not been very creative. Let's say that. Let's go to CoStub, right? I think that's who's next in line, CoStub, and then we'll go to Greg's question on compilers.
Yeah, Alexandra, you touched on a really good point there about giving yourself time. Excuse me, giving yourself time to be creative. I think that's really important. But there is another side of it when we complain about teams aren't being creative enough in the workplace, or we're not able to be creative enough. A lot of it comes really down to have we structured the team properly with the right variety of skill sets. Now, if there's a team of like 4 data scientists, you're dealing with a particular problem in one domain space, and all of you have the same background experience, you're all going to approach the problem typically in a quite similar manner, right? Like where I find some of the benefit is because I come from a bit of a weird background to data science, more from the robotics and vision side of things, I try to apply a different lens to things that say someone who's not from a robotics background might, right? So if we're able to bring our experiences from different areas of life into our problem solving process, what we basically rely on is what they call synthesis level thinking, right? And that's something that comes from a combination of time spent in a domain and time spent in multiple domains. So when we're structuring our teams, if we want to be creative in data science, we've got to structure our teams so that what I bring to the table is significantly different to what someone else brings into the table, right? So it really does come down to team structure. And then, of course, like Alexandra said, giving them the space, and like Gina said, giving them the leash to do it, to be creative.
CoStub, thank you so much. Thank you guys for participating in the opening question. A lot of great nuggets here. Comment coming in from LinkedIn from Amaninder saying there's definitely a price to pay when it comes to creativity, that is time and effort, and with not much guarantee on result. While our current work culture is result oriented, does not support scope for creativity. It was nice to know that Google gives its employees 20% of their time for creative projects, and many of Google's great projects came from these side projects. Yep, that's absolutely true. We'll go to Greg's question about compilers, but before we get to Greg's question about compilers, the other awesome news I want to share with you guys this week is I just heard that our community member Antonio and his wife just brought a baby boy into the world. So congratulations, Antonio. Go for it, Greg.
I put my questions in the chat here. To me, it's about having someone explain to me what compilers are. Who in the data science team should know about them? Is it the ML engineer? And what are the best practices to make sure that these ML models are built to be optimized from a sourcing, processing perspective, or is it applicable only, or should I worry only about it for edge cases where I read Chip Huyen's article about this, but anyone who has some insights about compilers would be super helpful. Especially like things like, are we going to see companies, design their own chips to optimize, for specific use cases, whether it does deep neural network or things like that. I know Mikiko, I'm happy you're here already, ready to rock and roll. So,
Mikiko, yeah, can you break it down and also just explain like I'm 5, like what is compilers, what's their relationship to machine learning, as well as Greg's question?
Yeah, so to be honest, I actually might not be the best person to describe compilers versus interpreters, mainly because I feel like, so at a high level, like compilers, they take source code and put them into machine code. And then interpreters, which then still has to be like repackaged into another stage. And then interpreters kind of go from source code to like the output. So they kind of can just run the program. So a book I'd recommend actually that I picked up recently is Crafting Interpreters by Nystrom. It's actually a really, really delightful read. And for me personally, I'm trying to get back into the fundamentals. I guess my question is, in a way, is how deep into the nuts and bolts does your team need to be? In the sense that, so even in like my company right now, like we're really kind of trying to figure out where do machine learning engineers like begin and end? Especially like in terms of how we navigate, for example, like software testing at scale. That's like a big thing we're trying to figure out right now. Is that something that like the data scientists should be writing? Is that something that like the ML engineers should be writing? Or is that something that should be like on the data infra side? Like how much of it should be automated versus sort of handcraft? So, I mean, and in terms of kind of like who would need to know like about compilers, I feel like for me, part of it depends on like what kind of level of tooling you're building. So for example, if you're building like in-house developer tooling that needs to be really proprietary, you probably do want engineers who have a really good understanding of things like how to craft compilers and interpreters. What languages should you be using? What are the sort of like trade-offs and kind of keeping up with that? Things like environment management, package dependency management. The engineers should definitely kind of know those things, but it kind of just depends on like what level of abstraction your ML engineering team is operating at. Because some ML engineering teams, they tend not, so for example, like my team, I feel like in some ways we're sort of mid to low level where we have to really care about things like dependency management, environment, setting up the environments for like the data scientists, because we're essentially providing in-house developer tooling, but we're not necessarily going so far as to like totally craft things from scratch. We still operate at a fairly like high level of abstraction, I would say. But some places, for example, like I imagine if you're like Waymo or Tesla, or you're doing anything self-driving, that would probably be much more of a concern, especially if you're dealing with like sort of more kind of real time. But I would say like it just in general, kind of like the question of, you know, who in like, so in the like the supply chain of ML, like who does what? I think a lot of those boundaries do tend to be a little bit sort of like gray. And it's I think a very big discussion at most companies, like who does what? Do you do the engineer? Do the ML engineers take care of the engineering? And when we say take care of the engineering, are they doing infra? Are they doing like in-house developer tooling? Are they doing customer facing stuff? So I do think that's like an active conversation.
Mm-hmm. Makes sense.
Let's hear from you on these compilers. Joe, do you got any insight? Joe or Ben, any insight on compilers? Kostab, go for it.
Yeah, I guess the other thing it kind of depends on is what's the software stack what's the hardware stack you're working on, right? Like if you're working on cloud computed devices, then a lot of it does get abstracted away from you because you are relying on things like GCP and AWS. But on the other hand, for example, when I was doing machine learning on a robotics system, we had to be a little bit more mindful of what the actual chipset was that was going on, like on the UAV, right? That's slightly different. So you need to start to understand a little bit of that more. But I didn't have to understand that as much. It was more the guys creating the chips. For example, in Australia, there's a company called Zalient, and they basically leverage some neuromorphic computing chips and stuff like that. I'm not fully clear on what they do, but they make vision specific hardware. And that embedded hardware basically takes whatever TensorFlow or PyTorch machine learning models I've created and can basically run that in a more efficient manner, right? And it's the same thing that NVIDIA is doing with TensorRT and the Jetson packages and stuff like that. So the guys creating those, the software layers between that specific embedded hardware and what I'm doing with my Python models, they're probably the people that really need to understand the depths of how far the compiler impacts the performance of your network, right? So we're starting to see that separation of skills. Like if you rewind 2 years ago, it was kind of like, hey, who understands embedded and understands a bit about ML? I'm sure you can do the job, but we're starting to see people specialize a little bit more, where people like, I'm really good at embedded programming for the vision space, designing for the ML pipelines. And you're seeing a couple of companies come up with that. And obviously, like Nikiko said, your self-driving cars, self-driving industry is really driving that in a big way. So we're starting to see that kind of split off as another kind of niche set of skills. But yeah, I mean, I don't know whether most data scientists or ML engineers would deal with it at that depth. But
would you say that your knowledge of the equipment available, let's say you take cloud out of the way, because cloud most likely will take care of that for you, but cloud can also hook you up with a hefty cost because of the processing on their platform, right? So if you could, would you say that understanding the capacity from a hardware perspective will influence what kind of models you would select to build for your use cases and deploy, if cost was something that you're really worried about? And as a constraint, I think understanding what the hardware does can influence how you deploy or what you deploy, right?
Yeah, I'm sure it will, but at this stage, the maturity that the industry is at, it's less a cost constraint. I'm talking about self-driving and autonomous robotics here, right? That industry is so young and so inherently expensive to begin with anyway, that it's less of a cost constraint exercise and more of a, do we even have the capabilities yet kind of exercise? Like we're still trying to get object detectors that can deal with 250 objects in the image in real time at 60 frames per second, right? And still have the kind of model accuracy that you need to keep people safe. So the first thing is, let's get to that, and then we look at cost optimization. So yeah, obviously it will eventually come into a cost question, into whether you go for whether you need to know that or whether you rely on abstractions like in GCP. And it's still unclear. The bigger reason that we don't use GCP as often on mobile robotics is, for example, if I put a robot underwater, you're not getting internet. Plain and simple. You're just not getting internet. So you need to rely on being able to use your local GPU or use a TX2 or some other kind of specialized hardware for it, right? So that's kind of where the decision point is at right now. But that'll change as the industry matures, right? So
cool.
Joe, go for it. Also, the stuff is going way over my head. Definitely got a lot to read up on here.
Compilers are good for people to know. If you're touching code, I don't think it hurts. Like in Python, for example, right? Understanding how bytecode is created and executed, like that doesn't hurt you, right? And like, when is it appropriate to use C, to drop down into C for primitives, or to use like the JVM, Java virtual machine? So I think these lower level things are something that data scientists eventually should know. I don't know that it's necessary. Like knowing compilers isn't going to make you like a data scientist out of the gate, but I think it's going to make you a far better one for sure. And just knowing how your code should execute, especially in constrained environments, we kind of talked about. So, but yeah, I don't know. At a certain point, I think it's just certain things that you should know in general, just basic computer science and algorithms and how that translates into bytecode, for example, right? And even diving into just how does assembly work, right? Like, the primitive language, for machine code. It's like, I don't think that hurts you at the end of the day to know how instruction sets are, how it's performed. You write Python, drops down to Python bytecode, and it drops down to assembly. Like, how does that work? Like, that to me it won't hurt you. But again, it's not something you're going to come across in your day-to-day job, but it's sort of like understanding why do doctors spend so much time understanding anatomy? It's not like you're going to come across this stuff every day, but you kind of do. So
yeah, to me, it's kind of like it seems like it's a good use case for ML engineers, right? So if they're trying to run their processing on the edge devices and things like that, so it looks like they need to have an understanding of what device to use, or what hardware to use on that edge device for compatibility. I think that article was very helpful for me that TPUN wrote. So thanks for your responses. I know, Mikiko, you got some more I'd like to hear.
Well, it's funny, like it depending on what teams or organizations you talk to, saying like the statement that, well, okay, the question of how engineering heavy should data scientists be, and what skills constitute engineering is an oddly controversial discussion. I've found in a couple circles because yeah, it's funny. We're kind of coming up against something like, in some places, conversation about like testing and testing standards and things like that. Apparently people have very, very strong opinions as to who that belongs to. So I imagine if in those same groups, if we were like, it'd be helpful if you learned like some more lower level stuff, it would just be madness, war, bloodshed, and tears.
Just to butt in there for a second, Mikiko, how much do you reckon that is more due to the history of the actual skill sets belonging to people, and how much is it more belonging to the way we perceive organizational structure? Like, we need to have an organizational structure where there's the test engineering group or the ML guys and the infrastructure guys, versus can there be a more fluid understanding of how we operate with different skill sets?
Yeah, and I'd actually love to hear Joe's take on this, because I feel like so years ago, right, we had the full stack data science unicorn, and there was this idea that regardless, that like the only real data scientist was one who was like end to end, had to know like 100 million things, and they were the only people who deserved to be data scientists, right? And that almost was a paradigm, like, what, like just 5-10 years ago. I mean, it wasn't that long ago, right?
Mm-hmm.
And I feel like we went from that to like, okay, everything should be like hyper specialized, and especially in bigger companies, you just can't get away from like hyper specialized, right? But I feel like there should be something a little bit more in between, and I'm not sure why in some places it's just so volatile.
There's a lot of gatekeeping though, right? Organizations, people want to protect their turf. I think it's just kind of how it is. I always used to make the joke that like data scientists are like the CrossFitters of data, especially full stack ones, where they're just kind of mediocre at everything. But it's changing, I think, to your point. Specialization does occur now, but it depends on the data maturity of a company, right? And so, but I think, yeah, it doesn't hurt to know, I think, of the primitives of each area of data, really. I think it only makes you better. So understanding, if you're a data engineer, you should understand how databases work, for example, at a good level. Like that, I just think that's necessary. But it's a tricky one. I don't know that's going to be solved anytime soon, unfortunately. Maybe you'll solve it here tonight. Who knows? But I kind of doubt it. So.
What pushed you to get that book, Mikiko? Like you said in the comment you just purchased a book about compilers. What was the pusher there?
Yeah, so because I'm not already just slamming my brain with a bunch of stuff, right, with the GCP studying and trying to get better at Jenkins and Kubernetes, right? Because I don't have enough stuff I'm shoving in my brain. I think part of it was like a recognition that, and this is really funny because at some companies, right, the ML engineering function is really data scientist plus. And in other places, it's considered engineering, and they're engineers that can happen to talk shop ML, right? And I think for me, I made what I felt like was a very informed decision away from data science to focus more on the engineering side. But I also recognize that like I have a lot of gaps in my skill set, which come up in like really weird ways. So, for example, like we maintain essentially insider developer tooling for our data science, right? So I can speak to them very well. But when something comes up in our tooling, and I'm troubleshooting, and then it's like, oh, well, there's this dependency like issue that then impacted like the environment that we were using and all these other things. Like I do find that I can follow along, but then I end up having to, I don't quite have like the conceptual underpinnings. And so I'm like, well, my company has a really generous educational stipend. So, and also recognizing that I've never really taken any sort of formal computer science courses. I kind of realized that I really need to reskill or upskill, depending on how you look at it. So there's this wonderful website called teachyourselfcs.com. And they have like a bunch of these recommendations for what are considered canonical like textbooks and resources. So there's a list of books they recommended: Computer Networking, the Algorithm Design Manual, Structure and Interpretation of Computer Programs, Thinking High Level, Writing Low Level, Crafting Interpreters, Computer Systems. Sorry, they're all on like this table right here. So it was just a recognition that like, okay, like I need to have my fundamentals, and I also need to understand kind of how sort of technology works right now, in order to continue like growing in my career as an engineer. As a data scientist, I feel like I probably could have gone away with not hitting a lot of that stuff for at least a few years. But as an engineer, I feel like it will actively kind of like hurt my career progression if I don't. I know that's a lot of mumbling words.
How much does that kind of depend on the team that you build around you? I mean, this kind of throws back to what I was saying earlier, right? Like for me, for example, I'm directing more towards the ML engineering role because I've got a background with the systems design and thinking of, very weird and complicated systems, right? That's what you get when you deal with robotics. So I'm more comfortable with that than with the deep maths of, being a pure data scientist. So I'm erring towards that ML engineering side myself. And like you said, I'm like way behind in all of this stuff. So I'm trying to crash course everything at the same time. But it's part of building the team around us. So right now I'm working a team of 3, and that's letting me, basically there's this multiplicative effect, right? Where we've got one person who's very deeply into the mathematics of the data science side of it. And then combine that with my more systems thinking kind of approach. Together, we're able to, both of us, do whatever level of specific model development that we need to do, whatever level of systems design that we need to do. And it's not just that, he does all the data science and I do all the systems thinking. We swap and trade skills in that manner. So as a team, you're kind of building, and you've got to build out a team in a way that I don't need to be an expert at the data science and the modeling part of it in order to do it, but I can get the support where I need to, where that's actually important, right? So again, and maybe I'm lucky and I'm in a company and a team where there's a bit more of license for fluidity. But yeah, that's pretty essential, I think.
Yeah, like it's a similar deal. Like we have people on our team who are like Docker, Kubernetes, Jenkins experts. And so in some ways, like because they are experts, it allows me to take the extra time to like go through the materials and like upskill. Because if we didn't have that diversification of skills, like we have some people who are what you would call sort of technical specialists. Like they are very deep in building the tools, big brains and years of experience. And like literally they can look at like an error that spit out in my log and they can go like, oh yeah, I think that like it was, and then just quickly Google search and go like, yeah, I think basically their newest release of pip like broke it. And I'm like, oh, that's you got that out of all of that, like all that red. That's what you got all of it. And then you have some people on the team who are like much more like, I think, strategic, and they like planning, they like figuring out like where do the different projects and initiatives fit, and they tend to speak very well with our adjacent teams. And then you have people like me where I'm like, oh well, okay, like I gotta figure out everything. But like that's what having like a nicely balanced like portfolio of skills like on your team kind of enables. And it does depend on like what is the core function of the team, like what's kind of the North Star that your team is providing, I will say. Because if your North Star is like meant to be like more internal business facing, for example, you're trying to drive strategic business decisions, having a bunch of engineers that are really deep into like the CS fundamentals, it might help, but frankly it might be better just to find someone who loves living in the strategy and analytics space. But if you are, for example, you're building custom tooling for like challenging problems like self-driving cars, that you can't just use like the current abstractions that are available. You really want to invest into those like deep like technical skill sets and people with those skill sets. So
Yeah, I think there's this we've kind of overfit across the last century. And this is an ongoing hypothesis of mine personally that I've been trying to test out in the last 5 years. That in the previous century, we kind of overfit on this idea of the master of one trade. As you know, there was always that saying, jack of all trades, master of none. You don't want to be the jack of all trades. I think there is room now to expand that thinking a little bit, right? If you go back to I'm talking like Socrates level eras, right? Some of the greatest thinkers were polymaths, and you don't even have to go that far back, right? You go back to Newton. He's a polymath, right? These guys were writing papers in many, many different fields. I'm actually reading a book called Polymath by Peter Hollins, which is all about mastering multiple disciplines, right? So I think there's this resurgence of ideas saying that you can have people who, wheeler dealers that can deal with the business side of things, can deal with strategic, can deal with a little bit of technical depth, right? There might be value in having a balance of, like you said, technical specialists that can deliver that code value, but also can think strategically and, work outside of that team. And this is where we've got to move beyond having, I'm trying to hire this one rock star data scientist that's going to solve my whole business, right? So it's kind of leading me to this thought that is data science inherently, from a business analytics perspective, inherently better as something that you would hire out to a company or to like a consulting service, as opposed to necessarily build in-house, because it's a difficult team to build in-house, right? So can you leverage it better as a consulting team?
Can go for it. And also, Kosub, can you share a link to that book or just type the name of that book out?
Yeah, not to go too far down the rabbit hole of the mastery versus a jack of all trades thing, but that's something I think about quite a bit. And I think in 2021 or in today's age, like composite specialization is something that rules supreme. So I'm not the best at this individual thing. Like, let's just take like data science, for example, right? Like I am probably not even like a 75th percentile data scientist, right? But if I combine that with my abilities in content creation or video editing, I am probably a top like 5% person there. If you combine that with my sports analytics knowledge, between those three domains, I'm like top 1%, right? I might be the only one doing those things, but that also suggests that I'm unique and can create value in that way for someone who has those specific questions. And I think rather than really like narrowing down and specializing in like a specific like technical domain, if we're spreading specialization over a composite group of unique things, we're able to create that differentiation and create the real value in that domain. So it's like we're becoming more specialized, but we're also less specialized because we have these composite skills. And it's like this, I wouldn't say it's a paradox, but it's like a weird refining of that thought process, right? And it doesn't fit neatly into a mastery mindset or a jack of all trades mindset. I think that the optimal skill set going forward is you're really good at like one or two things, and you combine those with other things that you're pretty good at, and that makes you valuable to as many people as possible. I still believe that like if you have some expertise, let's say you're in like an 80th percentile in something, and you can combine that with a bunch of other 50th or 60th percentile skills, that gives you a lot of scale and a lot of specialization still to maximize on both of those things. So maybe a little bit different way of thinking about it. Maybe I'm just rambling, but I just love that idea in general. I know Harpreet and I have talked a lot about this too.
Yeah. So like the rest of that quote, jack of all trades, master of none, like the second half of it is oftentimes better than master of one. So that's that talent stacking thing, right? You just, be top 25% in a few different things, combine them in unique ways, and all of a sudden you're the best in the world at being yourself. Yeah, that's kind of the direction you want to head towards. Greg, great conversation kicked off there. Let's head to Mark's question.
Yeah, I actually think it ties in really well to the previous conversation. I'm just more so thinking forward, kind of like next career moves. Not necessarily new company, but more so like what type of data role do I want moving forward? and specifically moving away from data science. I'm realizing that I love being an IC, I love being technical, but like analytics and like machine learning model building just as a career just does not provide me joy. I like it for side projects, but for the job itself, I find it to be way too reactive for my liking. And so trying to think like what's brainstorming, I'm stuck between data engineer and ML engineer as roles, but they're two different paths. So just trying to choose one is go for it. And so essentially, just want to brainstorm like what are some career paths beyond data science that really lean into that technical side?
That's a great question, and it's something I was thinking about earlier today too. It's like I can write code, I get done, but like I don't really enjoy sitting there writing code all day long or doing like grunt work type of stuff. Like I like kind of architecting a solution, right? Like if I could just talk to like some junior level data scientists, like, all right, cool, we got this data. Here's some things that we need to try to do with it. And here's kind of a blueprint and path of things that we should do. Get it right up to the experiment point. You do all the coding up to there, and I'll take it from there. I'll do the experiments and find the best fit model and evaluate it and stuff. So like that's kind of, I was having that same thought earlier today. I was like, man, like I enjoy data science, but I don't enjoy all aspects of it, particularly grunt work, coding type of stuff. So I'm very keen on hearing other people's responses here as well. But slowly and surely, people are dropping off. I'd love to hear from. Let's go to Ken and then Greg on this, and then anybody else wants to jump in. Mikiko. And do you want to jump in here?
Yeah, I think Mark, that's a really good question. I am neither a data engineer or an ML engineer, so I don't think I can provide too much insight on that front. I will say
also it can be ML engineer or data engineer, just the ones I'm aware of, but you can think of like some wild other one I'm not aware of too. It doesn't have to be those two buckets.
Yeah, I mean, to be perfectly honest, I do like a self-assessment of about once a month. Sometimes I push it off to once a quarter, where I evaluate where I think my strengths are, but I also evaluate my enjoyment of certain activities. I try and like audit essentially everything I do over the course of a week or a month, and I rate how much I enjoy doing those things. I rate how much like effort it takes, how much energy it takes, a lot of different ways that I frame the same thing, and then I try to match that to the roles that I'm currently in. Like what roles would allow me to be as efficient and effective as possible while it not feeling like work for me. Like the more I'm realizing this, like let's take the content creation that I do, right? I find that nowadays making YouTube videos for me is a little bit harder than filming podcasts. I love talking with people. It's something that feels completely effortless for me. When I have a conversation, like connecting with another person, it's dynamic. It's something that flows rather than making a video. It's pushing, like it's static. I am doing all of the delivery, right? And thinking about, okay, like I still enjoy both, but how do I slant things so I'm doing more of one of those other things? And that's something I have complete control over, right? But the next logical step, if it was my domain or my work, is to say, okay, what types of activities or responsibilities can I pick up that would flex those exact skills? And you don't, if you love your company and your management team is receptive, in theory, you should be able to like just evolve your role to doing more of the things that really feel effortless to you, and doing less of the things that you find tedious or struggling through. And rather than looking at it as like, hey, I'm going to switch, it's like, I'm going to take what I'm currently doing and slowly progress it towards this other thing. And you can get a new title, you can do whatever you want, but that's how I would generally approach that situation. Not like clear-cut advice or anything like you probably wanted, but that's sort of my 2 cents on that front.
Greg?
Yeah, so I definitely like your framework, Ken. For me, it's about more where do you see yourself sitting in an organization? I like to think about it in terms of front end of an organization or back end of an organization, and you can have different positions inside of it. Most of the time, the back end, you're building products or you're taking care of infrastructures that serves or enables or enable internal teams. So do you want to be a builder of these infrastructures? Do you want to build products that serve internal teams versus do you want to build products that serve external customers? So there are multiple places you could go. You could become a product manager. You can be a systems architect that builds, these systems, that looks at the big overview of these ML pipelines, and kind of like an internal consultant in around these systems. There are definitely different things, but the first thing is, where do you want to be? Because you could be a solutions architect for external customers, or you could be a solutions architect internally that are looking at ecosystems that are enabling internal teams. If you want to go beyond just the data science of things, you'd have to take a look at where you want to sit inside of an organization and see what kind of problems they're solving, what kind of tools they have to solve these problems, and then how can you apply your skills, which is mostly around data science, to solve these issues. And then you can figure it out, right? Most important, you're young. Try as much as you can, because time is your best commodity, man. You're better placed than most people right now. And the time to try different things until you figure out what you like, what you don't like, is now.
Let's go to Makiko, then CoStub, and then that's Google Data Science Solution Architect. That is an actual job title. There's a bunch of job postings on this. Really interesting to look into. Let's go to Makiko and then CoStub. And then if anybody else has questions, let me know. Not a lot of people joining us on LinkedIn. Not a lot of questions coming in here, so this might be the last one.
Yeah. So when I had I talked to my past director, because my team. So to complicate the plot, my team MLeng got moved into the data eng org. So to complicate the plot, or data services, but it includes a bunch of data engineers. So. But when I had the talk, so I had a conversation with two directors, my current director and the past director, who is still in the company, but whose team I moved out from under. And one director basically said, think of it in terms of where you fit along sort of the spectrum from from tech specialist to tech lead to tech strategist. Because even within an engineering organization, there is a really wide variety of work that people do. You have some people, and this is true even at certain levels. For example, you can have a staff or a principal engineer who is a tech specialist. They build all the tooling inside, they do the research, they, whatever. But you can also have principal engineers who are mostly tech strategists. So they're focusing on what tool stack do we incorporate? If, for example, if you're going cloud like AWS or GCP, and let's say you start out in a monolith, which of those services do we invest in and do we move out of? How do we sort of communicate the company's strategic positioning to external users or something? So there's, even within engineering, there's a very, and the technical contributor route, there's a wide variety of work that you could do. For me personally, I don't see myself as a tech specialist, frankly. To some degree, I kind of feel like I started out my engineering career a little bit too late. Really only within the last 2 years. And I'm older than 30 now. So in some ways, I kind of feel like if I had wanted to go the Jeff Dean route, I probably should have started studying computer science in undergrad. Which I'm fine with. For me personally, I see myself as more of a tech lead, tech strategist. I'm very, very interested in how to design systems. And I'm very interested in the trade-offs between when do we use some solutions versus others. And I love building products. That's what it comes down to. I really hate getting into the nitty gritty of what libraries do we use, debugging stuff. It's just a necessary evil to me. I'm not in love with trying to come up with new languages, using new languages, trying out new languages all the time. For me, all my work and all my investment is, can I build stuff that people can interact with, whether they're internal or external? And so for me, that it makes sense to align with like the tech lead and tech strategist. But very similarly, like my other director basically was like, said you should be like in people management, because they were like, you have an innate ability to lead people and to get them to do things even when they don't want to do it. So, and his advice was very similar. He's like, you're young, like he's like, feel free to bounce in between stuff, like try different things, because at some points you're going to want to like do technical projects, but other points in time, it's like he's like, you're not going to want to deal with that bullshit. You're going to want to like, help enable other people and other teams to do really big stuff. Because at the end of the day, really, really big, like moonshot goals, you have to have teams. Like maybe you have like 3 to 5 10x engineers if you can afford it. I mean, but realistically, if you want to get big stuff done, a lot of times you're not building it yourself. You're going to have like a team. And so for some people, they have more joy, it seems like, in rather than saying like, I built this feature myself, they can say, I built this platform or solution, or I helped enable the, deployment and the creation of this solution by gathering like the best people around me and like, making sure that they are developed. So yeah. So in terms of the data ML and kind of ML ops kind of thing, to be honest, it seems like the division is a little less, there's not as much of a division as you would think. If you develop skills on the ML and ML ops side, you can transfer a good amount of it over to the data end side and vice versa. But yeah.
Go for it.
And, I guess. Sorry, go on.
Oh no, I was gonna say, and would love to get Ben's input on this as well. So Mark, if you just want to type out the question you had in the chat, so Ben is queued up on it. Kostab, go for it.
Yeah, look, I mean, I'm still trying to figure out exactly what my path is as an ML engineer, robotics engineer, computer vision. I don't even know, right? But like, so it's, for me, I could go down a technical specialist route, but I know that I also have some skills and enjoyment in A, strategic thinking, in B, thinking about systems at a higher level, and as well as, just leading a team. Like we seem to constantly talk about, there's two kinds of data scientists. One, which is, your deep technical specialist and your business strategist, right? What about the people leaders? As we start talking more and more about teams, you need people that can lead people, but still understand data science, right? Like the best product managers I ever worked with when we were building like, electromechanical devices were electronics engineers who understand the pain that, the mechanical team and the electrical team are going through. So your people managers and your project managers, there's all of these different roles that are coming into the into the ML, I guess, ecosystem, right? Development ecosystem. And really we tend to overcorrect and kind of say, hey, I am this career because this is my like training, this is my degree in this and that, right? But that's not the sum of all parts, right? The sum of all parts is, what are your other experiences? What are the other things that you've done and your natural skills, your personal tendencies? So like, I can't remember who, I think it was Ken that said he really analyzes his skills as a whole, right? You got to come up with that Venn diagram. And it's something that I revisit that at least once a year, if not once every 6 months, and really look at what's changed since the last Venn diagram. And that's how I'm hoping that'll inform me going forward in my career and where I can head with that. It's a way. I don't know if it's the right way. I'm not at the end of the path yet, not even close. But yeah, it's really about understanding where all that fits, right? So there's more than just, hey, I need to be the technical specialist, or I need to be this particular thing. That comes back down to that pigeonholing thing, right? We need to be a bit more fluid.
Yeah, I mean, it's interesting, like this role I got now at Comet, how it just kind of seems to coincide so nicely with kind of my specific knowledge and what it is that I'm interested in, right? Like I'm not necessarily like the business data scientist type of guy. Like I don't really care about reporting to stakeholders and doing business stuff and stuff like that. I care more about the creative aspects of data science, building models, doing interesting stuff, educating people, communicating data science and things like that. And I seem to have found myself a position where I get to build data science models, write about them, create presentations, communicate, educate, and do a lot of creative work while still being closely connected to like data scientists and data science work. And then, I guess try to find opportunities like that. So roles like this are coming up if this is kind of like the path you're interested in, like, and they tend to be mostly on growth teams or marketing teams, like I guess like advocate is product evangelist, ML advocate or developer advocate, things like this. But yeah, I mean, it's all about just finding interesting intersections of your unique skill sets. But Ben, go for it. Love to hear from you on this.
On the Mark's comment, career path beyond data science.
Yeah.
Okay, so I'll start with something negative and end with something positive. So the negativity is jobs are not charities, jobs are not free, and having paid payroll, you need to have a multiplier. You need to have a multiplier value. But the positive side is you can actually make up your job. Like you can make up your job as long as that's true, as long as there's a multiplier. There's attribution is true of every department, sales, marketing, and data scientists. Really good data science leaders know their attribution. And I see this firsthand. Really good data science leaders will say, this is my attribution for my entire org this year. And it's a number with a dollar sign. And so my first year joining Data Robot, I don't think I coded for like a full year, which is maybe a little weird because I came from very high performance, deep learning, coding all the time, every day. So really it's just kind of aligning your passions. And I think for some of the people here on the call, they like podcasting, they like speaking, they like blogging, they like writing. So just, I think there's always going to be an intersection of AI with whatever your core passion is. And whatever you do, it just find something unique and really push into it. And you can make up a role that we've never heard of, but it has some AI flair to it, as long as there's attribution to that role, which can be there for so many reasons. Anyway, I loved Greg's comment on jar brain. Jar brain's been breaking my brain lately. Anyway.
Yeah, it's funny. Lawrence Moroney over at Google, I think he's one of like the lead TensorFlow advocates or something. I forgot what exactly, how high up he is, but like, some people I've seen especially like at Google or Amazon, where they're like developer advocates, they have some of the coolest jobs because it seems like their entire public time is they use like either Amazon or Google's tools to build cool shit and go, look at all the cool shit you can build using these tools. They do a bunch of projects and then talk about how cool the tool and technology is, publish like content around it. But they literally get to see projects from like end to end. I feel like in some engineering organizations, you kind of just live in like one of the stages of the pipeline. So if you're QA, you just QA everything. If you're ML and you live in some part, if you're data eng, you live in some part. But a lot of like the developer advocates or even like the evangelists, they can actually take a project to production end to end. They have that creative autonomy to do that because they're there to showcase like their company's tools. So to me, I'm like, if I get to the point where I'm like, I just don't want to even anymore, I feel like that would be such a cool place to try out. Such a cool role to try out. Yeah.
Well, maybe to lean into that real quick, Makiko, I've been teasing other people in the data science community because I'll send them a text and say, data science is hard. I'm smoking cigars in DC, or like I'm drinking wine over here. But this is always focused on like partnerships, right? So getting back to attribution, there are so many interesting. So we talk about selling, like peer-to-peer networking, but there's also like business networking where it's quite complicated. We're trying to prioritize these partnerships. And so for me, that is really, really fun. But it has data science, like data science is all over that. Like, how does a partnership actually work? How does it make sense? What are the integrations? But these all start at a human level.
I will say, like, one of the perks I enjoyed working as like a data scientist on like the customer success side was getting all the perks of the customer success team, right? And especially too, if you're like a client facing data scientist, right? Like they'll bring you to the meetings, they'll bring you to the kickoffs, they'll bring you to the sales summit. Sometimes that's stressful too, like in especially like technical sales, right? Because if you're actually one place I've heard people go to is like sales engineering. That is actually one place I know some data scientists go to. They go to sales engineering or like customer success engineering because they like the like 9 to 5 aspect of it. And or a lot of times when they do work, it's like around the end of the quarter or like so it's around like the sales peaks, but their entire thing is still, once again, like building stuff, making it look cool. But working as a data science, as a data scientist on the customer success side was really fun. Yeah, I think I got flown out to like Boston, Vegas, Switzerland. Could have gone to, I think, England and Italy for Autodesk, but I just didn't want to. I didn't want to. So,
Makiko, we should push a trend that hashtag data science is hard. And anytime you're like drinking wine or an African safari, if it's tied to the job, that would be hilarious. Just, I wonder what the junior data scientist would think. Wait a second, that's not data science.
oh yeah, I did that when I went to like Tel Aviv for work. That was great. The beach on Tel Aviv, going to the cafes like on Instagram. That was fun.
This is super helpful advice, and also for context, a lot of my work and like things I try to go for is just, like, I view it as training for the next time I try to do my run at like a venture-backed business and trying to build one. And so a lot of my focus now is like, how can I build really quick and iterate really quick? Because that's like the furthest I've gotten really in like trying to approach those startups. But the other end of it is like, all right, cool. Once you build it, get funding, and you grow a little bit, you need to build a team, and that's a huge gap in my learning. But I also hate the idea of management. So still in the learning phase, but yeah, that's why I'm really focused on just like building cool shit really fast.
I'm a big fan with startups early on to only hire principal talent. So you actually don't have to manage. You hire people that know their domain, they're experts at it. And that's awesome. If you have to mentor and manage, then for an early startup, that is awful.
Yeah, just kind of
That's
jumping
comforting.
on top of that, like just kind of jumping on top of that. I know that I'm not like fresh, but I'm also not nearly, at principal talent levels, right? So my focus right now is actually on scaling, right? I'm trying to work in a team right now that I joined a few months ago where we're working on scaling data science models. So if I can build my niche across the rest of that data pipeline, there's so many people focusing on how can I develop and do these proof of concepts really quick. There is still this gap in how do we scale that into a large scale product, right? There's not many people who know how to do that. So that's something that I'm trying to learn. It's a different set of skills that's within the data, manifold of jobs and technical skills. But I kind of wanted to latch on something that Ben mentioned a bit earlier. You said basically, like, end of the day, it's about having that attribution, right? That dollar tag figure of what value you're providing. Like, I don't know if I'm calculating that always the right way. How do you go about processing that and assessing what's the real value you're providing?
Some things, it's a hard science, and then it blurs into the gray. And so sales is super easy. Like they can have attribution marketing as well. But there's things like brand equity or data science. If you do some innovation, it ends up in the product. What is the value of that? And I think what you see in all these domains, there is a science where people are trying to hammer all the way down to hell on what the value is. And so if you go ship a feature, a very mature product would actually know how many customers are using it. Was it mentioned in Salesforce as a differentiator during the sell? And people attribute it back. I'm not saying that's easy. A lot of companies really struggle with that.
But it's also not just that I'm the only person creating that feature, right? I'm part of a large team creating feature. So how you got to assess what's your, like, you kind of have to look at it at I've started to look at it more at a level of how are the things that I'm doing amplifying the speed at which my team can deliver that feature, which delivers this dollar figure value to the company, right?
Yeah.
And conversely, what am I doing outside of this specific role, which is scaling this pipeline? What are the other things I'm doing that add value to the company as well?
Yeah.
And that's a bit more of a mixed pot to balance.
Yeah. I think one of the general themes is how close are you to revenue generation in long term? Like if there's company cuts or pushbacks, it doesn't matter what role you're in, you kind of have a sense of how close you are. So if you can't like spit out a number immediately, the number should always be greater than one. You should always feel confident that there is a true multiplier to what you're doing. But some people, they are in roles where they're very far away from revenue, and that just becomes more problematic. I think maybe I'm different. I think I like being as close to it as I can be, but also I like blue sky innovation that is maybe falls in the brand equity bucket, which is very messy. It's so hard to assign
Yeah.
value to brand equity.
I guess the other side is that maybe this is something that like younger data scientists like myself need to be a little bit more aware of is what's the value? Can you tell me the value of the product you're actually building, right? Like we should know that as a data scientist that, hey, we're building this piece of software. It's going to earn this many $1 million a year, right? Or is it $100,000 project or a $50,000 project? If we don't know that, I think that's a critical thing to understanding the value you're providing.
And that is something that a lot of these engineering projects, they actually do give revenue commits. So for the bigger strategic projects, they don't just say, we're going to go do this, it's important. They say, we're going to go do this. Here's a revenue commit. And if that revenue commit is not met, then your name's attached to it. So, and it's funny, those revenue commits, when you look at them, they're always nice, big round numbers. So it's like 1, 2, 3. It's never like 200,000, 350, or like 2.6 million. Like it's not really a science, right? It's finger in the wind, but the accountability's there.
It's usually divisible by 5.
Yeah.
It's usually divisible by 5. And I think too, like, so devil's advocate here, I would argue that if you have like leadership that at all levels is very well aligned on what the North Star is and what the strategy is, as an individual contributor, you don't necessarily need to know what your like revenue contribution is. In that, so what you don't want in some ways is you don't want to be working on a sinking ship or like a feature factory, right? Because with a feature factory, you can have features that do bring in extra revenue, but it's like incremental. It's almost like you don't know if it's actually pushing the needle on anything. It could be like an extra lift of like, okay, so for Amazon and Google level, right? Like an extra lift of 2%, that's a lot of money. That's a huge amount of money. For a company that's doing 1 million revenue, an incremental lift of 1 to 2 to 5%, it might not be good enough, depending on like how expensive your engineering talent is. So I feel like, but I think that's the hard part, right? Is that like at some point, especially as a company gets bigger, like you'll have teams which they are just, for what reason, they're working on this product, which someone knows it's going to get sunset in like a year or 2 after it gets launched. The engineers are not necessarily going to know it unless they are willing to kind of go up and go across and talk to the teams like next to them, or well, I don't talk, like understand what the adjacent teams are doing and what the sort of like overall roadmap is and where do they kind of fit in that. And ideally, I feel like if you have like a really strong leadership and it's perfect communication all the way down, most people would be able to track that, but I've yet to see that, frankly. Seems like it falls apart at some level.
Kind of a problem of scale though, right? Like in a smaller team, like a mid-sized team, it's like, 40 to 100 people, maybe that's very easily communicable, right? The moment you get to a few thousand people in a company, there's competing strategies because you've got multiple business opportunities that you're chasing. You've got, different business opportunities that are like you're already milking a cash cow here, but you got a rising star that you're developing that it's just competing strategies, right? So it's hard to communicate that across a few thousand people.
Mark, hopefully that was some good insight for you there. I want to go to Greg because Greg had a question for Ben. So then we'll go from Greg, then we'll go to Gina's question, then we'll call it a day after that. Thank you everybody on LinkedIn. I'm sorry I can't get to all of you guys' questions, but hopefully you guys are enjoying this.
Yeah, it's a quick question about JarBrain. Like if you've seen any interesting answers in your post about this one, about that concept, if you want to explain to the audience what you're working on there.
Yeah, AGI I think is really fascinating for anyone in AI. It's kind of like this I love how AI has the intersections of psychology, neurology, philosophy. Like it's kind of nutty that it all, or you want to understand your life's purpose. Like all of this kind of like blends in this really weird point. And people talk about singularity AGI. And the Turing test was the first one, but the thing I really don't like is you have like GPT-3, like you have these massive neural networks that will train more data than humans could ever learn. And I like to focus on randomly initialized AGI, what could it do? And so the what Greg is mentioning is I posted on LinkedIn and I proposed this problem. Called it the Agi game. And I said, look, if I could rebirth you, go back in time, you're not going to learn to speak English. I'm going to rebirth your brain in a jar and you can consume a video feed. That's it. This video feed is going to run for 25 years. I have an AGI. It's literally smarter than you. Like, that is a fact. It is smarter than you. What can it do 25 years later that you can't? And I think that's an interesting discussion. Like, obviously things like search would be very trivial. Humans, our memories aren't quite good. If I showed you a frame or a video sequence from 3 years ago, you would have a hard time knowing exactly in time where that was. Maybe you could place it. Maybe you couldn't. So I just think it's a really fun discussion. There were some interesting questions. I think Greg kind of put me on the spot a little bit where I was trying to recall who had the most interesting answers. I know, Greg, you responded, and I liked some of the insights that you had. I'm trying to recall. Maybe Greg, since you're on right now, search would be top of mind. Predicting would be top of mind. AI is anticipating what's going to do, but just your human brain does it too. Like, you're anticipating what I'm about to frog. Like, your brain is anticipating what I'm going to say next, and we're pretty good at it. But AGI would be a little bit better at anticipating what is next. So if I had to plot intelligence is not singular, right? Like, you have different dimensions of intelligence, emotional intelligence, et cetera, et cetera. But if I had to pretend like it was this continuous scale, think of it as being plotted on time and space. Your comprehension of time and space. If an AGI is smarter than you, can predict further in the future what someone might do or what might happen than you could. But it could also comprehend space better, the things around, understanding what might happen. But I like that problem that I brought up because this AGI is not allowed to interact with the environment. And so it's actually putting AGI in the worst possible position to learn. I don't know. I'm just curious how anyone reacts to that, because people always freak out about AGI. It'll become infinitely smart in a month. And I'm like, yeah, that's fine if it can do stuff. But what would it do if it literally can't? Your jar brain sitting next to the AGI jar brain.
So it's kind of like you're exposing AGI to only that environment, right? That even AGI itself is constrained to whatever it sees on that video through the years, and we'll be able to apply brute force to predict in a longer horizon than the human brain, right? Our long short-term memory is not reliable to perform those tasks. In this case, AGI will be a little bit smarter or much smarter, but there are some other things that humans experience that AGI is not aware of. Yeah.
Will the AGI have an ego where if somebody in the kitchen drops a glass of water, my human brain might take it personally, like, oh, this fucker's just fucking with me, dropping a glass of water because I can't. What will the AGI think? Right?
I think with that limited input, it's really hard to have self-awareness. Like, you can't look in the mirror, you can't touch your face. So you, even as a human brain in a jar, you're just kind of anticipating what's next. Like, oh, here's the humans again. You actually don't even know you're a human. If I could rebirth you in a jar. It's funny because people keep coming up with new Turing tests. I don't know if you guys have seen some of these. They're like, oh, the Turing test failed, so the new one is this. And I'm like, oh my gosh, are you kidding me? I think one of the Turing test options out there is the new Turing test is AI will be able to comprehend anything in the sequence of videos. I'm like, that is the dumbest thing ever, because I can brute force train. We will brute force train in the future, and then everyone will celebrate. We passed the Turing test because you trained on like a gazillion videos. So I hate the parlor trick. I don't want a parlor trick. I just want to simplify it to the simplest use case and work backwards. Let's actually talk about what this thing would do. And if you can talk about what it'll do, you can actually talk about how you'd build it. So if it would have,
I have a quick question. So if, for example, to a point, Harpreet, I come in the kitchen, I drop something on the floor because I'm mad versus I made a mistake. I think the AGI will see that differently, would take that as two events of dropping something on the floor as a data point, just as it is, versus a human brain would say, okay, there's a why behind it, right? Maybe the human brain will have more intuition into guessing whether the person is in a bad mood versus good mood. But now I just heard you say, even the brain doesn't know it's a human brain. Now that brings a little bit more complexity to it now. Well,
it is, you can give examples where you could The example I throw out that the general AGI community maybe doesn't talk about that much is for those two systems, if I come down there at night because you can't see, and if I put a pitcher upside down, or if I shrink the fridge, or if I do something, if I change a number on the microwave, now the 9's not there, it's not there, AGI is going to notice it immediately. As soon as it comes on, bam, the novelty's there. AGI is, oh, something's different. The human would too, but the human is more likely to miss subtle pixel level changes, where AGI would immediately get it. Something's different.
Like the human consciousness is a filtration mechanism, right? Like we filter out more than we take in. That's otherwise we just wouldn't be able to handle it all, right? So the machine wouldn't, right? Like the machine can handle everything, process everything, right? So yeah, I don't know where I was going with that, but we filter everything out. We have to.
Doesn't that kind of filter into the main issues of AGI, right? You're talking ability to represent the world at the same kind of fidelity that we do in our brains. Like we've got the kind of sensing, like the sensing resolution, effectively, for lack of a better word, right? To be able to construct these high fidelity maps of the world around us in our brain, right? Like in the field of robotics, that like the sensor challenges around that alone are starting to add up, right? Then you got the power consumption issue, right? Is sure AGI might be able to do things to greater levels of detail and attention than a human brain would over a long-term, short-term kind of inefficiency that we have built into us. But then where do we come across this point where this is a case where AGI would really work because it's more like power efficient than us? So it's all about efficient intelligence as well, right? And to your point, Ben, you're right. It isn't like the latest Turing test that just, hey, can you do this task that's seemingly difficult for current day technology to do? But if you really want to know about a Turing test, you should be asking, can it, like Harpreet asked, can it develop a sense of ego, in the philosophical sense of ego, where you're saying, I identify myself, a sense of identification, right? That's when you start getting these higher levels of thinking. And that's the difference that you see between between lower level ego creatures in the world. Like you see that difference between dolphins and monkeys and, right down to insects, right? There's different levels of ego representation and understanding of who I am as a person, as a perceiver, as a human. We're able to see that we are this physical person, but then we're also this observer behind that, watching that physical person. And then we're an observer behind that, watching the observer, right? We can see these layers of abstraction and symbolic learning. So, and all of this, we do this taking 1,800 calories in a day, right? So the significant challenge with something like AGI, in my gut sense, is how do we find those challenges that AGI would be apt for within the power constraints that it would just be unreasonable for us to just get humans to do it, right? And do we then boil it down so far that it's just turned into a more specific artificial intelligence and no longer considered really AGI?
For the power limits, I do like to go the opposite way and just gift it infinite memory and infinite compute just for the thought experiment. Because I think as you get into AG, like here's a great example. One milestone that would really impress me is to have an AI system that learns to speak English through experience, like literally in your home. You have a baby, you have this AGI system, you talk to it, you interact with it. It's gonna be focus-based learning. You'll smile, you'll give the same cues, that you're excited that it repeated some word. If it can begin to learn the English, and we actually know those different milestones with humans, that is very impressive. But the compute, getting back to your compute efficiency, I would argue to do that today, the compute would be disgusting. Like it would actually kind of make you cry a little bit. And there would still be a big question mark of whether or not that would even be possible. Because the big thing that's missing is search recall. Because you would actually have to do search recall on petabytes of data in 100 milliseconds. Because if I say hot dogs, you immediately, bam, the AGI exploded that term out. The first time it heard it, one-shot learning, talk about zero-shot learning, so compute and memory already kind of hurt when you start talking about that example. But look, your brain, brains did it. The brain's a miracle.
The question in my mind is that, like, you're absolutely right. Like I look at my niece, look at any toddler, right? You show them a really vague conceptual cartoonish drawing of a tiger, but then they understand every representation of a tiger, whether it's hand drawn, a realistic sketch, a photo, a 3D model. They understand that it's a tiger. We as a human brain, we do this symbolic learning, this representative learning that's inherently different to the experiential learning that we're seeing with most AI models these days, right? Like I think, I don't know if that's a construct that we're missing, like a software layer that we're missing, or we're missing some piece of this puzzle in terms of reaching that symbolic level abstraction. And I think that's when we're going to start seeing a significant step up in the efficiency of learning, right? And that's going to start making these more general artificial intelligence systems more and more viable. You bring those power costs down, you bring the your ability to abstract out, like you said, we're not going to hone in on that detail of a number 9. How do we get a machine to do that? And then you get the philosophical question of, should we be building that at all anyway, right? Should we not just let humans do what we're good at, which is those abstract learnings, and augment us with these specific AI that can look at the detail that we miss every time?
I think the transition you're going to see as we head there is, think of it as an incredibly useful AI. So AI systems that actually exist to make your life easier. And so they're constantly working to, like, imagine an AI system that's cleaning the house and it finds a problem. Hey, this power outlet's broken. It's bringing it to your attention. And if you don't like it, think of like the Ring camera, false alarm. That is something the AI will quickly react to. It doesn't want to interrupt you unless it's actionable insight. And so, or the Mars rover actually being useful for 30 months without, or like, for a year without human interactions. It's kind of these autonomous AI systems. They're not conscious. It's not singularity, but you're going to see this natural trend in the next 10 years where AI is desperate to please you with actionable insights. And if it's overwhelming you, you will be upset and it will have some reaction to that. It doesn't mean it can't actually be sad, but I think that's a funny dynamic that might exist in these smart homes where you begin interacting with them. And I think we've talked about how that could be ethically bad to personify AI. Think of like the AI therapist. So I come home, I'm talking to the home. My wife's mad at me. Why isn't your wife mad at you? I'm telling the home it's not alive. But if it has this personification, that could actually mess with me. It would definitely mess with kids, but it could mess with me where, so I'm laughing, Greg, thinking about this, because think if this system actually became tuned to my experience, and then there's a firmware update and it screws up my system. We would all laugh and say, oh, it's okay. Don't worry. You'll get the new initialized personal assistant. I would actually experience emotional loss because I have developed, does that make sense? Like I am developing an interactive relationship with my personal assistant who's adapting to me, and it's been personified. A year later, something screws up and it's not backed up. I will actually experience emotional loss as a human. And now what does that mean? So personification of AI is super problematic. Yeah,
it's something we've got to be mindful of. Like for me, one of my favorite quotes from the year 2035 is "I told you so" by Isaac Asimov. So we've got to be a little bit mindful of that.
An interesting discussion for sure. I sent a link right here in the chat from a video by this YouTube channel called Pursuit of Wonder. Name of the video is called Digital Psychosis. It's a very Kafka-esque 12 to 15 minute video, which plays on the metamorphosis plot line where, how the guy woke up and was a cockroach. This guy woke up and was a computer. And it's kind of exactly what Ben's talking about. All he could do is sit in his room and has a camera and just observes things happening as a computer. And they're talking about how in the background he has this program running that's actually his base level consciousness. It's pretty interesting. Good 15-minute watch. Definitely give it a watch. It's also here on LinkedIn for you guys to check out as well. Right on, guys. Well, thank you very much for the.
Sorry, Arpreet. I feel like I always take things down the rabbit hole of uselessness.
I wanted you to go there, man. Don't be sorry about that.
This is great. Hey, man, this type of stuff I like. I mean, I enjoy hearing it and hearing other people talk about it. So,
fun fact: if you put a nightshade over the AGI system in your kitchen, it actually can't learn to speak English, but neither can you, because humans need focus-based learning. You actually need so like that quote: you can't learn English listening to the radio. It's actually problematic for your brain. You can learn patterns, but you need the focus-based learning, which is fascinating because you look at how kids learn a language. Everything's focus-based. Wow, baby's tracking eyes. Of course it is, because that brain is ready to, it's in overdrive to learn everything that you do, which is so amazing because we even see this in the animal kingdom. Empathy, emotional intelligence, like a baby hippo is very sensitive to behavior of adults and other hippos right out the gate. And so it's, and even your baby is sensitive to your novelty reactions. Oh, wow. Like you as a parent, you have a novelty reaction. Your baby is very like keened in on that, which I think is just so fascinating.
No, it's true. Like I remember my kid said something yesterday and just made me chuckle, and he just kept saying it, and they kept saying it and saying it, making me laugh, and he was laughing while he was saying it too. It's cute. Yeah, man, babies are crazy. Like simultaneously like learning deep learning and then watching my kid grow up and doing the research and drawing the parallels between human intelligence and deep learning. It's just so fascinating to see in action. Well, guys, been an excellent discussion. Hopefully, you guys tune in to the podcast release this week with Eric Oken. I got a few awesome stuff coming up in the next couple of weeks. Next week, I am interviewing live streaming with Natalie Nixon. She wrote a book called The Creativity Leap. It's here somewhere. I'll be giving away a free copy of that book as well. She was kind enough to give me 2 copies of that book. Also speaking to the data professor himself, Mr. Channon, or Dr. Channon rather, on the 23rd. I'm speaking to Marcus Dusatois. He just sent me a copy of his new book. Really excited about this. He also wrote the book, The Creativity Code, which I've talked about multiple times on this podcast. Excellent book. So super excited to talk to him. He's a professor of mathematics at Oxford, the Simony professor of public education of science or something like that. So that is going to be exciting as well. Also got a live stream happening with Danny Ma on the 28th, and got a live stream happening with Dave Langer, and eventually I'll get to all of my friends. We'll get to all of my friends. Ben will be on the show at some point. So will Tom. So will all the friends. So I'm excited about having all of them on. Greg, you've already been on the show. I got Greg on the show before he was famous. Guys, thank you so much for taking time out of your schedule to be here today. I appreciate you being here. Remember, my friends, you've got one life on this planet. Why not try to do something big? Cheers, everyone.
Thank you.